ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करुवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। Now, Kavita, please start.
Sure, sir. Could you make me the host so that I can share the screen?
Yeah, I am making you host. One sec. Now you are host, so please start the program.
Yes, sir. Let me share the screen. Is my screen visible?
Yes, it is visible.
Okay. Okay, so in today's lecture, we will be starting with a new unit, Unit 5, where the first topic is sampling and the theories of sampling. So Yashwati, do you have an idea on what sample is? Yashwati, are you there?
Yes, ma'am.
Yeah. Could you tell me what a sample is?
Sample is the small representative of the population.
Exactly. So, are you aware of all the types of sampling and everything?
Yes, ma'am. Probability sampling and non-probability sampling.
Okay, great. So, today will only be a revision session for you, as you already know all of these things. But we will quickly run through all of this because now that we have made and revised our first draft of our tool, our task will be to pilot test it, for which we will need to decide on the method of sampling and then the sample population, sample size. So for all of that to even begin, before we begin the pilot testing, there are these things that we need to decide on. Hence, there will be this session where we quickly run through all of the basics. Okay. So as you said, what is a sample? Sample is a representative group of unit from the overall population, which has the desirable characteristics which we want to study. So when we choose a sample, so here it is said, a social researcher has to collect information about a universe that consists of vast differentiated population spread over a large territory, and that too within a limited amount of time and money. So the whole purpose of taking a sample, because it is impractical to be able to measure the overall universe or the overall population itself. So we choose a sample which is representative of the whole population and generalize accordingly. So that is what the whole purpose of sampling is. But when we say that we are sampling, what should be the desired characteristics of a sample so that it is actually representative of the population? So the first one, it says that a proper sample must give a precise but also correct picture of the population from which it is drawn. So if we say in Indian population, then our sample should also consider individuals from multiple states of the India. Otherwise, if we are only choosing a sample of Bangalore or Mumbai, then that sample will only, the results from that sample will only be able to generalize within that Bangalore or the Mumbai locality and not being generalized to the whole Indian population. So, according to the first point, there should be a correct picture of the population from which it is drawn. So, the sample must be precise. Second, the sample must be obtained by probability process. So, when you say probability, you told that there are two methods, probability and non-probability method. So, using statistical process, we make sure that there is some or the other kind of probability process through which we ensure that every individual has a one or the another equal or unequal chance of being a part of the sample. The third is it should be economical as possible and gather swiftly to be completed within the time schedule. So the whole purpose of choosing a sample is to be able to do it efficiently within a time restraint and financial restraint. So before we even start with all of the sampling, there are few concepts that we need to be clear about. So what is the difference between universe, population, and sample? So when we say universe, it is much more umbrella term and much more the general term of being able to define a collection of people in which one is interested. So in other words, a population consists of people who are related to this specific problem under investigation. For example, if we are studying the relationship between class achievements of the university student and the methods of teaching, then the students of any place and any time will come under population. So if you are studying the voting behavior or political participants of the citizens of India, then all the adult citizens of India living in India or outside will come under the population. The universe on the basis of the characteristics could be divided into these types. So when we say univariate population, it means that within that population, there is this one dominant characteristics which we are considering to study at a time. So that characteristics can either be age, income, sex, TV, listening habit, any characteristics that we want to study on. But when it comes to bivariate population, the population can be defined as a bivariate type. So when we say bivariate type, it measures two characteristics simultaneously of each member within that sample. So in sociology, we often are interested about seeing how these characteristics, when we measure two characteristics, why do we measure? Because we are interested to study what is the relation or the association shared between these two characteristics. So for example, we want to know how crime going habit varies from urbanites to ruralites, or how political participation is determined by the degree of political awareness. So in these situations, we are measuring two different kind of characteristics, which can either be urbanites or ruralites, or their various degree of political awareness. So that this way, the type of variation within a population will decide what kind of population or the universe you will be choosing. The third kind is multivariate universe. So when we say multivariate, it says more than two or more than three characteristics which are under observation simultaneously. So when we observe multiple characteristics at the same time, there are several social factors that play together in the occurrence of one event. So for example, if there is a car accident on the road, it is often caused not only by the mechanical defect in the car, but also other factors like driver's mental or physical condition, or the sheer volume of the traffic, or the improper signals that occur during the crossing, or even it could be due to the behavior of the pedestrian itself and not at the fault of the driver. So there are, in this case, several factors that play in the role of even a single event like a car accident occurring. So when we study all of the social factors within a single member in a universe, then it is called multivariate universe, as there are multiple variations which are under study. So when we say population, when we say, then we often speak in terms of the population characteristics. So when we say Indian young adult population, then I am talking about its age category. When I'm saying female population, then it is more of the characteristics of sex, or when we say lower socioeconomic population, then it is in terms of income. When I said before about individuals who are residing in Bangalore, then it is about residents. Similarly, there are various characteristics on the basis of which we will be selecting the sample. So what characteristics are to be measured depends on the nature and the type of our problem under investigation itself. So if I am looking for any kind of binge watching addiction within the young adult population, then my sample will have the characteristics of being under certain age criteria. So now that we know what are the types of universe, what is population, then there is something called stratum. That is another concept that you should be clear about. So when we say stratum, what does each strata mean? So it can be understood in terms of the population. So when I said in the previous example that we are studying a certain behavior of the whole Indian population, then the population can be again divided into various several subpopulation or several group. So here, for example, a given population may be divided into different stratums on the basis of cinema going habit of the people. So simple action of going to cinema itself can be divided into several strata. So first will be males who visit cinema frequently, males who rarely visit cinema, males who visit cinema occasionally, and males who do not at all visit cinema. So thus the number of stratum would depend upon the number of characteristics that you want to study. So when we say internet addiction, then it could be individuals with lower addiction, who does not have addiction, who has average addiction, and who has severe addiction. So this way I can again divide the population according to this strata. So stratum is the word used to define a population into several subpopulation. And now moving on to several element of the population that we should be known of. So sample, we talked about how sample is the aggregate of the object, people or element selected from the overall universe. So it is a sub portion of the total population, which is very representative of the population itself. So now other things that we should be known of: sampling. When we say sampling, sampling is the process of choosing that sample. Census is when each and every element or the unit of the population is studied. So when we conduct census, it is a overall study of each member within the population. Now that we have gone through the basic concepts, the next thing that we have to refresh is what are the advantages and disadvantages of sampling. So the first advantage is it helps to collect vital information more quickly. So when it says more quickly, is that we are saving time in terms of rather than taking and collecting information from the whole population itself, we are collecting information only from a small samples. When properly selected, it helps to make an estimate of the characteristics of the population in a shorter time. So when we are choosing a certain, if I say that internet addiction is predictive of family dysfunction, then within the sample that I have studied, if that is true, then I will be able to generalize that within the whole young adult population, the scenario will be same. So this was possible in a shorter time due to sampling. The next point is that the modern world is highly dynamic. So any study must be completed in short time. Otherwise, the time that is needed to complete the survey itself would bring out. So if I'm conducting a survey, if I've started conducting a survey by the January, and it takes me 1 to 2 years to able to measure the whole population in itself. And by the time I am able to publish or disseminate my findings of the research, by the time I do all of this, by the time the information and the findings are out there to be able to make decision on policy making, by the time it is out there, it would have been too late, because the trend at which the internet addiction was affecting dysfunction would have changed, or the development of the technology itself would have brought new problems other than the one that we have already shared about. So that is the One other good thing about the sampling that it not only saves time in terms of collecting or analyzing the data, but also in terms of being able to put the final findings out there for the to earn the benefits of research. The third and the foremost is that it is able to cut costs of the whole study. So when we say cost, it is not only in terms of the money that we'll be investing or the funding that is often used, but also in terms of the personal resources and the time itself that is invested in a study. The third is, the fourth is sampling techniques often increases the accuracy of the data. So with a small sample, it becomes very easier to check the accuracy of the data. And sometimes other kinds of sampling techniques even makes it possible to measure the reliability of the sample estimates from the sample itself. So now using the sample techniques, it increases the accuracy of data. When we have the more big population, the sample size is often estimated based on our confidence intervals and the margin of error. So this using all of that and using and deciding and being able to estimate and come to a decision of the ultimate sample size, we are able to ensure the accuracy of data which is enough to come to a conclusion. So anything more than the sample size would also increase, but also there is a chance of it causing a lot of sampling errors and biases and being able to contribute even non-sampling errors that will affect the study. So being able to sample and use the sampling techniques is also good in terms of increasing the accuracy of the data itself. The last point in terms of advantage is that from the administrative point of view, sampling becomes very easier because it involves less staff, less equipments, less resources and everything. So management is easier. So it becomes possible to go much more depth in and much more depth exploration about any characteristics that are under study. The next is disadvantages. So what are the disadvantages? Sampling is not feasible when knowledge about each element or unit or statistical universe is needed. So this comes even in the study of LGBTQ community, where in order to estimate a sample size, we need to know the overall number of transgender community or homosexual members existing within a community. But as it's an information that is not readily recorded, we do not have a overall number of the population. So when we do not have the overall number of the population, it is harder to estimate a sample size, because an estimation of a sample size is always made on the total number of population. So if my total number of population is 100, then using the confidence interval of plus or minus 5 and the confidence interval of 95 and the margin of error of plus or minus 5, then I'll be able to say that my ideal sample size will be 79 or 30. But in this situation where I don't even know what is the total number of population or the universe that exists, then estimation of sample itself becomes very hard. So knowledge about each element or the unit or the statistical universe is often necessary. The second is the sampling procedures must be correctly designed and followed, otherwise what we called as a wild sample would crop up with misleading results. So when we are going further and looking into the types of sampling, then what occurs is that there are several sampling procedures, and then we'll also be covering the advantages and disadvantages of each sampling procedures. And by being able to evaluate these strengths and weaknesses, you should be able to choose the correct sampling procedure. So where a simple random process was necessary, simple random sampling was need to be administered, but at the same time you ended up using any other non-probability, then a lot of deficits and disadvantages of non-probability sampling will affect your study, and all the significant effect or the effect could be attributed to the sampling bias and errors rather than the characteristics of the universe itself. So being able to choose the correct sampling procedure itself is very essential to ensure the quality of sample. Here, a very large sample is required in order to yield enough cases for achieving statistical or reliable information. So, in various numerous situations, to what extent will a unit even vary will have to be decided using the sampling procedure. The third point is that to know certain population characteristics like population growth, population density, census of the population at regular intervals is more appropriate than studying the sample. So according to the purpose of the study, you have to even decide whether sampling is the right approach or not itself. So what are the techniques of sampling? So as Yashwati rightly said, there are two, probability and non-probability. Yashwati, could you give me in very short what is the difference between the both?
Yes, ma'am. Ma'am, probability selection, probability sampling is needed, gives random. Actually, I don't remember.
Okay, no problem. That's why we are revising today. So the main
Yes,
difference between probability and the non-probability lies in the term probability itself. So when we say probability, then there is equal chance of the each member to be chosen for the study. So when there is 50-50. So here if you can see the example, 1 minute. So here is the example. Every probability can be expressed in terms of the proportion. So the probability of getting a head or tail when we are tossing a coin is half. So one chance in 2 tries. So when we say probability sampling, then it is just saying how every member within that sample has equal chance of being selected for the study. Because as you said, we use a lot of techniques like simple random method and systematic sampling method, where the method of choosing itself is based on simple random selection. So when we say random selection, then every individual or every member within that universe or population has equal opportunity to be selected selected to be part of the sample itself. So in the sample, like example, each element has the same probability of being included in a sampling. So that's the main demarcation between a probability sampling and non-probability sampling. Non-probability sampling is often done when probability sampling is not able to be fulfilled. The needed limitation, no, the needed criteria for probability sampling, when these are not fulfilled, then we end up doing the non-probability sampling, which will be more clear when we revise the various sampling techniques that are used. So there in the non-probability sampling, each member that is chosen to be included in the sample do not have the equal chance to be selected. So the chance is based on several criteria or the characteristics that are under the study and not based on the simple random choice. So let's move on to the probability sampling technique. The first one is the simple random sampling. So simple random sampling is where in very carelessly manner or the techniques that are told or shown here, lottery method, tippet number method, the grid method. So here randomly each member is chosen. So it is not based on there will be a there will be general characteristics which are chosen. So young adult population. But within that young adult population, every young adult has the equal opportunity to be chosen because like how we say lottery method. So I am writing name of all the young adults and putting it in a ball and choosing one name at a time. So here every chit had equal opportunity to be selected. So I am selecting each member randomly. So that is called simple random sampling. So this kind of thing is used often to decrease the biases which are affecting the results of the study. So if I am conducting an intervention study, I might know that by being able to provide this intervention to certain clients who have the motivation to change, and certain characteristics that will allow the intervention to be used successfully or effectively, then I have a bias, because by choosing the client itself, it is not only my intervention that is bringing about the change, but also the personality and the characteristics of the client itself. So when I'm choosing a random sampling, then I'll be able to objectively see if my intervention was successful or not, because the randomly sampled individual or the sample will consist of random members who are varying, who within which there is a variation, and those variation will be able to be seen in a very objective manner. You will be able to test your effectiveness of intervention in different and diverse population. So the results that you get will also be very objective in nature when it comes to saying that yes, this intervention can be used within the young adult population. But when you use and choose the client in a biased manner, or client or the inpatient or the participant in a biased manner, then you will not be able to generalize the results saying that my intervention can be used within the young adult population, but rather it could be like it can be used within young adult population with introverts or extrovert personality trait. Like for example, if I say that my intervention will help in overcoming stage fright, and then when I make such an assumption or a claim, I am saying that no matter what is the personality trait of an individual, my intervention module can equally bring the effectiveness and reduce the stage fright. But when it comes to simple random sampling, I might randomly choose individuals with multiple and different and varied personality characteristics. But if I am choosing in a biased manner, then I might end up already choosing individuals who are extrovert in nature, for whom it is relatively easier to even stand up and talk in a or overcome their stage fright. So that is the main advantage of the random sampling technique, that it is very simple, because it involves, so that when you say the steps of the simple random sampling, the first step is you have to list all the elements in the population. So when you say element, it could be the members within the population. So when I am saying, like for example, in your class, so I'll be taking a list or the attendance of your class, and then every individual or every student within your class will be assigned a roll call number. So that way I will be making a list of all the elements in the population and assigning them the consecutive number. Then upon which I'll be estimating the sample size. So when your class strength is 100 and I've chosen the sample size of 80, then using any method of sampling that we will be covering here, lottery method, grid method, tippet method. So all of this method, I'll be choosing randomly 80 individual within that list. It could be odd, even, or is I am choosing all the odd number, roll number. Then that is one method of simple random sampling. So like that, multiple methods can be used to randomly select, where all of the 1 to 100 roll call individual had the equal opportunity to be equal chance to be selected for the study. So by doing this type of, or using this type of sampling technique, we are ensuring that the sample is representative enough, because there is not even one cluster, first 20 individuals that have been selected, or the last 20 or the last 50 individuals that have been selected. So when we even decide on only choosing the first 50 roll call number, you don't know on what basis the roll call number is even assigned in the first place. What if the roll call number is assigned in terms of their mark? That means the first 50 individuals are the most with a high IQ or high academic ability. So that itself will affect your research study in itself. So being able to provide a representative sample is the whole aim of simple random sampling method. But when it comes to disadvantage, the first and initial most difficult thing is to find the data list of all units of the population to be sampled. So when I say LGBTQ cure community or individuals who do not have a ration card, and I want to estimate people from the below poverty line. So in all of these situations, I do not have a list of all units of the population itself. So if I do not have all units of my population, I will not be able to neither estimate the sample size nor be able to assign them some number or choose them on the random basis. And the task of numbering every unit before the sample is even chosen can be very time consuming and expensive, but there are a lot of now softwares and everything that have been used to randomly and simply select. The computer itself will choose a certain number for you, so that reduces the researcher's bias. So the lottery method is the one that I told you about, how every name is written in a certain chits and then shuffled through thoroughly through a box, and then the tickets are randomly drawn and the name or the number of the individual is noted. A Tippett number system is where there's the Professor L.H.C. Tippett had developed like a list of numbers, and each set of these numbers were 4 digits. So the numbers are written on several pages in an unsystematic order. So the sets of number that we have already assigned to every individual, we need not even decide the set of number as it already exists. But our task is to be able to link a number with an individual. So once we have linked that, according to the set of number, the Tippett numbers, we will be able to select the individual according to the Tippett numbers. The next one is the grid method. So the grid method is more overused when it comes to deciding on a geographical location or anything. So like for example, you have a map of the whole town or the city in your hand. Then the area is often divided into different blocks or districts or town locations. And a transparent plate which is made equivalent to the size of map that consists of several second holes in it, which carries different numbers. So 1, 2, 3, like that. So when I go from one town to another, that kind of screen or the transparent plate with dots and the numbers will on it will be able to decide which numbers are to be included in the sample itself. So all of these are techniques where in no way the researcher's bias or the researcher's desire to choose a certain sample or the unit is being able to affect the study. The next type of probability sampling is systematic sampling method. So in the previous one, it was a simple random one, but here we are choosing, even though it is a probability and every individual has the equal opportunity or chance to be selected, it is quite systematic in nature. So when we say systematic, the steps of doing this is to list or make a list of all the elements in the universe, but on the basis of certain selection criteria. So when I say criteria, it can be on the social characteristics, like we only decide that within young adults, I want to study differently the students, the working individual, the professors, like that. Or within the young adult population, I want to use members from different lower socio-economic class. So here I am systematically creating a certain category with which I'll be able to choose individuals who have those social characteristics. So a list will be prepared either in an alphabetical order, like for example, how in our either roll call, the name is written in alphabetical order, or in the old telephonic books and everything. So from that, I might be able to choose in terms of a systematic sample. So when I say every third or every 10th individual in that list will be selected. So it's not simple random sampling where I was randomly taking, and it could have been that while I'm using the lottery method, the first 10 individuals who have been chosen is from the first 50 students in the class who I said have a high academic ability. So even though it was simple random sampling, there was a chance of it being on the not being able to come up with a representative sampling. But when it comes to systematic sampling, we are saying every third or every 10th of individual in that class. So in that way, we'll be able to kind of make it work in terms of how random it actually is, the sample that is being chosen. So the advantage of doing systematic sampling method is that it's very direct and it's very inexpensive, because all you have to do is put them in the alphabetic order and choose the random third, second, or fifth individual. When a list of names or items is already available, this is quite often the efficient approach. The disadvantage is that in case of exploring unfamiliar areas, because listing of element itself is not possible. So this was something that was shared in the previous sampling technique as well. But another disadvantage that happens is when there is a period fluctuation in the characteristics under examination in relation to the order in which the items appear. So if, for example, when I said the first 50 individuals are those with higher academic ability, but what if those 50 individuals, or even from the 100 individual, the way it is named is that I had chosen 10 individuals from different dimensions. So when I say, from different division, A, B, C, D, E, F, G. So like that, there were 10 divisions, and then I am choosing 10 students from each division who are being ranked according to certain academic ability. So when I choose 10 individuals from the division A, they may have already been ranked according to their academic ability. So the number 1 will be the individual who has the highest score in the class. And then again, when from the division B, when I choose 10 individuals who are again ranked order in certain manner, then when I join them, then the 11th individual in itself will again be individual who stands first in that class. So even though I have chosen, even though the list that is being made, I do not know, but there is certain pattern that exists within the list. So according, what is that pattern? So in the list that I have gotten, without me knowing, it is actually 10 individuals taken from different divisions who are rank ordered according to their academic abilities. So in the list, you would be able to see that every 1, 11, like that, every 10th individual is automatically individuals who have the highest academic ability. So here, the problem is that even when we are getting the list, we do not know in what way was the list even prepared, or it is already existing. Is there already a pattern to which it was made? So when we make an assumption that it is a fair choice, it might not be the scenario. So that is one of the disadvantage. Then we have the stratified random sampling method. So in stratification, what happens is that a population is divided into different strata or groups. And then we call it as stratified random sampling, because each strata is then either chosen by simple random sampling process or regular interval method. So when we say that each population is divided into different strata, what relevant criteria is this stratification done? It can either be due to age. So young adult, middle, elderly population. So like that, I am stratifying, or based on the family income or number of years of education, occupation, religion, race, place. So based on several characteristics, I'll be able to stratify any population. But when we say stratified random sample population, that even though we are making stratification in the first step, after that, within that stratification, so for example, sex, male and female stratification. So when I'm doing that stratification, after doing that stratification on the basis of characteristics, then I am choosing randomly using the simple random method the sample within the both male as well as the female. So first, initially the population is divided into maybe 50 male and 50 female. Then the sample will be selected on the basis of maybe 20 from male and 20 from female. So when I'm choosing 20 from male as well as the female group, then I am using the simple random sampling method. So this is how stratified random sampling method is often calculated. So an estimate is made for each stratum separately. So when I said 20 and 20, the estimation was in terms of that number 20. It wasn't like 5 from the male, 5 from the female, then it wouldn't have been a proper stratification, because equal number of members did not represent the each strata that I have classified. So the whole purpose, why is there a need of doing stratified random sampling? So the whole primary purpose to increase the representativeness of the sample without increasing the size of the sample on the basis of having greater knowledge of the population characteristics. That is, when I know that there is a significant difference between the variable that I have under study affecting the female population and the male population, then it, rather than taking information from 100 individual and understanding that I have only 30% of female and 70% of males, then that sample itself will not be representative of the whole population that I have under study. So being able to conduct the stratified random sampling method, you will be able to estimate in each stratum how many individuals you need. So that way, when you're going to starting to conduct your study, you will know I need 20 female and 20 male in my study to be able to have a sample that is representative of the population in itself. So that is the whole primary purpose of being able to stratify the sample in according to certain characteristics and then using random method to choose each member within that sample. Then we have the advantage of being able to do so. So the different groups are sure to have, as I said, different representation in this sample. So when I say about how males express loneliness or males express psychological distress would be very different from how females express psychological distress. So if we are studying any variable called psychological distress, then the way it acts within the two groups should be studied separately other than together. So when if they're studied together, then we will get mixed results and there might not be a chance of getting a certain trend or pattern within the psychological distress of the overall population. But if I have a knowledge that variable acts differently in two groups with different characteristics, then I'll be able to divide them according to the two group and see how each variable acts differently in the two group. The next is, with more homogeneous population, greater precision can be achieved with fewer cases. So in terms of, even if we had 100 individual with mixed sex, that is male and female all together, then I wouldn't have been able to see the pattern of how certain addiction affects my self-esteem. So this pattern wouldn't have been possible if I had not separated them according to the sex. So for example, gambling addiction or even gaming addiction. Gaming addiction impacts and can be seen more in males rather than females. So if I had both of them together, then the patterns that I would have been seeing wouldn't have been significant. But if I would have separated them, then I could have seen that significant results were found in the male population and not so much in female. So again, if I'm doing this, then I might have a bigger population if I'm not already stratifying them before. And then there is 100 to 200 individual in my study. And even though I have 100 to 200 participants in the study, I'm not able to come up with any pattern or conclusion. But even if I have 30 or 40 individuals in male and female, which only results to overall 80 cases or 80 participants in my study, I'll be able to come up with more precise answers and findings just because the kind of sampling technique that I have used has ensured a very homogeneous population, which will give me greater precision, because the homogeneous population or subpopulation has certain characteristics which are common. So now, even when you see another advantage is that as compared to the random samples, these stratified samples are geographically more concentrated and thus save more time and energy. So when it comes to the taking or collecting of the data, we will be able to focus where to invest money and energy. But when it comes to disadvantage, you can see that unless and until there are extreme differences between the strata, the expected proportional representation would be small. So here a random sampling may give a nearly proportional representation than the another. So until and unless we do not know that what is the difference between both the strata, it is difficult to use this kind of stratified simple random sampling. But then even after stratification, the sample that is selected from each stratum is either by simple random sampling method or by systematic sampling method. There are various drawbacks within both method that we had seen, and that can both contributed to this sampling technique as well. So for application of the stratified method, one must know what are the characteristics of the specified population in which the study is to be made. So for example, if I say individuals with higher scores in depression, or who has mild depression, or who has severe depression. So when I say that, then I have to be very sure about the characteristics of individuals with mild depression in the Indian population and how it manifests, and what are the characteristics of individual with severe depression in the Indian population. So only when I know what are the characteristics will I be able to stratify them. Similarly, what are the extreme differences between these strata should also be known. So here, but if you see overall, this whole process of stratification can become quite complicated and difficult because there are a number of characteristics. So when I said depression, there are a lot of factors, biological, mental, which comes under this category. So being able to even classify or put them under different strata is difficult in itself. So now that we had talked about stratification, in the previous example, I had told 20 and 20. So that was a proportionate stratified sample. There is also something called as disproportionate stratified sampling. So when we say disproportionate, then it says that the disproportionate stratified sample, also known as equal size, in this method. So what happens is I said it the other way around. So in disproportionate stratified sampling, equal number of cases are selected from each stratum, irrespective of the size of the stratum in the universe. So sorry, I made a mistake there. So when we are talking about disproportionate or proportionate, then it is talking about the overall number of the members that are already existing within the universe itself. So what if when I go to a class, then there is 25 females and 25 males. So that is where the case of where already equal number of cases are being selected. So if already in a class, there is 25 males and 25 females, and all I have to do is choose 10 from both the samples, then it becomes proportionate. But when we say disproportionate, it is more about how already in class there is only 20 females and maybe 40 males. But irrespective of how many males and females are in the class, I am choosing only 10 males and females. So this is called controlled sampling, where the number of cases to be selected has already been decided. So here in the example, it was 10. And irrespective of whether the number of individual in the class, female and male, were equal or unequal, I had a controlled sampling method where I had restricted the number of individuals to be chosen, that is 10 males and 10 females. So advantage is when equal number of cases are taken, the comparison between the equal number of cases is justified, because then it is not because just because the sample number is more in one place that the significant difference was seen, but rather in terms of the characteristics that are different in itself. Similarly, the controlled sample prevents the investigator from securing an unnecessarily large number of schedules for most prevalent groups of population. But at the same time, the disadvantage is that it requires the weighing of result stratum by stratum. The relative frequency of each stratum in the universe must be known to be able to even estimate. So how we had said in prior, how we should know the whole size of the population to come with the, to be able to estimate the sample size. So here it is same. Even though it might not be equal number of even though it might be equal or unequal number of universe or the members in the universe, we should be known to be able to even restrict to a number of designation. Then the last one, as we said, here there is a list of all striatum and the proportionate size in total population. Since the size of the stratum that itself varies, the number of people that coming from each stratum in the sample should be on the basis of the selection of given percentage of people, which also will vary. So now in this scenario, you can see that the advantage is that there is some kind of definiteness, definiteness. But the disadvantage is that the researcher might end up having poor judgment or inadequate information upon or on the basis of which the stratification is itself made. The greater the number of characteristics on which we are to be able to stratify, the more the strata or the more complicated the strata will be. So when it comes to be able to secure a more proportional representative of each stratum population, it becomes extremely difficult. The next technique of sampling is cluster sampling. So what is cluster sampling? It is again a method of using stratification, that is choosing a subpopulation. But here the group, so in previous example, what we had seen is that the group were homogeneous in nature. That is, males and females had equal homogeneous characteristics due to which they were stratified. But when we are conducting cluster sampling, it is more of heterogeneous in nature. So when we say heterogeneous, each group will have varied characteristics which are present. So here the elements or members are not selected from each strata as it was done in stratified sampling, but rather each member is obtained by taking a sample of group, not from within group. So that means that out of several clusters of group, 1, 2 or more number of clusters are selected by simple random sampling. So let me explain to you. Now, for example, I want to study the mental health of students in an overall college population. But if I see within the college population, there are several departments and several year students, first year students, second year students. So the use or the method of using cluster sampling is being able to choose a group. That is, either when I say several clusters or group, then I am choosing either a cluster of people. For example, first years from all the department will be one cluster. Second year from all the department will be second cluster. Likewise, PUC student will be third cluster. Like that, I have made 3 cluster. And from that 3 cluster, I choose individual samples. So 10 individual from first year who are from all the department, second year who are from all the department, and then PUC student. So this way, from the various clusters who are differing in terms of their characteristics, I am choosing the sample which is representative. So likewise, another example could be in terms of conducting a survey in bank itself. So being able to, I will not be able to assess all the bank branches within the India. But what I could do is that within each state, I could choose 3 bank which is representative of that, all the collection of banks within that state itself. So choosing 3 banks from each state is where from each cluster I am choosing a certain sample, and then by coming up with a sample population which has randomly selected members from each cluster. So this way, it is not only stratification that is done in certain characteristics, but rather a group of characteristics. Here, in cluster sampling, the cost per element is greatly reduced because I'm not considering all the bank, but only 3 bank that are randomly selected. It becomes now possible to take a larger sample and regain the amount of precision. It can be used in situation where it is impossible to obtain sample by other methods. But the disadvantage is it is a complicated sample design where the researcher has to be highly skilled in sampling, because as we said, it was quite complicated to even explain of how a single cluster exists and how to even choose a sample from each cluster. So the whole design itself is very complicated and the researcher needs to be highly skilled in the process. The last is multi-stage sampling. So here you can say that when we say stage, that is within using in each stage, the methods that will be used might differ. It can be cluster or random sampling. But if I want to give example of multi-stage sampling, it is like, for example, we want to study a population with different socioeconomic background, attitude or motivation, and I want to study what is the socioeconomic background, attitude and motivation of slum dwellers. So first for that, we will make a list of cities. That is all the metropolitan cities that exist, and then I will create clusters of slum dwellers of each town within that city, and then within that each area I'll be choosing certain slum dwellers. That way, those sample of slum dwellers will be representative of the overall slum dwellers that reside in the city itself. So here, first thing that I did was to be able to choose the cluster within one city. But then again, I'm doing the same cluster sampling in another city. This way, in similar way, from different city, when I keep on doing or using the cluster method from different slum areas, there is this multi-stage of sampling that is being considered. So when we say multi-stage, so the first stage was itself to be able to choose sample population from each city itself. But we didn't even, we not only collected samples from different city in itself, but within a city, from all the slum areas that existed, we equally collected each a correct amount of slum dwellers existing in these slum areas. So when we say multi-stage, it was not only in terms of the city, but within the city, the individual slum areas that exist. So that was the slum areas, the secondary sampling units, and the primary sampling units was the city in itself. Then we move on to non-probability sampling. So in non-probability sampling, there is various methods that are used. So when we say non-probability, then the individuals or members are used for certain, are selected on the basis of certain characteristics. So when we say accidental sample, then here the individuals are chosen on the basis of one or the another method, which was very accidental in nature. So for example, one is studying the political socialization or the political participation among university and college students of AU, and the sample size was 100. So he could go to the researcher could go to the university campus and would select the first 100 students that he meet. So that is accidentally ending up or choosing an individual first 100 students. So here there is no stratification or making a list or making a lottery method or any other kind of cluster sampling, but rather choosing the first 100. So in this scenario, could you say that every member had the equal chance to be selected? No, but it was rather on the basis of the researcher going and choosing the first 100 students. So that is called accidental sampling. The second is called quota sampling. In quota sampling, the interviewers are interested to interview a specified number of people from each category. So it is kind of like stratified simple random sampling, but here the individuals that are chosen in itself already belong to each category. So the required number of elements from each category are determined in prior to the study of before choosing. So thus an interviewer would need to contact a specified number of men and specified number of women from different age category and different religions or social group. So the basic purpose of quota sampling is the selection of a sample that no true replace of the population about which we want to generalize. So for example, when it comes to different religion, then I am choosing a specified number like 50 men from Hindu religion, 50 50 men and women from Hindu religion, 50 men and women from Christian religion, 50 men and women from Sikhism. So like that, based on the different religious group, when I choose 50-50 individual, then the sampling that I'm doing is according to the quota. So what is that quota? The different religion that exists was the quota. So according to the quota, when I'm sampling and creating a sample, then it is called as quota sample. But the added advantage is that if you properly plan and execute, what are the characteristics of a quota in itself, then I'll be able to bring a maximum representative sample of the population. So when I wanted to study conduct an interreligion study, and my population consists of equal number of individuals from various religious community, then it would be a maximum representative sample. But if I had missed on collecting samples from different like Christianity or Islam, then that study will not be equally representative of the sample. Hence, my study could not claim that it went in depth to study about different religions equally. So having only 5 individuals from Christianity and having 15 individuals from the Hindu community in itself will not be representative of the whole quota itself. So in purposive sampling, one picks up the case that I consider to be typical of the population which needs to be studied. So when we say purposive sampling, we are choosing the participant based on certain characteristics that we want to study in itself. So we are choosing that individual because that individual has certain characteristics that we want to study. There is no equal opportunity for every adult individual to be chosen equally, but rather I am choosing an individual in the study who has severe depression but also engages in substance use. So there was certain characteristics that I was looking for, which was typical of the population that I am studying. So here the type of sampling method that I'll be using will be purposive sampling. The next is convenient sampling. So when we say convenient sampling, it is often the last approach of sampling because it is more of about the convenience of the investigator to be able to choose a sample population on the basis of availability and not on the basis of being able to equally sample in a very representative manner, either by creating a strata or a quota. So here it is not simple random, but rather more deliberate or judgment or like unsystematically coming up and choosing random 100 individual on the basis of convenience, on the basis of availability. So when I want to study college students, and if I end up studying only, I want to study the whole college student population. So I should be doing multiple from different state, either cluster sampling and using other sampling techniques. But if I ended up studying only the student population of my college itself, then that is convenient sampling, where the investigator or researcher is choosing the sampling on the basis of his or her convenience itself. Now that we have gone and refreshed ourselves throughout what are the different techniques of sampling, the next question that comes across is what is the size of the sample. So even though we have a formula to estimate what is the size of the sample that needs to be decided, we should also within the formula that I'll be showing you, there are a lot of decisions that we have to decide. That is the confidence interval or the margin of error. So to come up with such decision of how much should my sample size be, these are some of the components that we have to keep in the mind. So to be able to even decide what is the sampling technique that will be used, the number of sampling units that already exist in the population itself needs to be known. So another thing will be different opinions have been expressed by experts on the point on what should be the sample size. Some suggest that the sample size should be 5% of the size of the population, while others say it should be 10%. However, these views are little used in practice because no hard and fast rule can be laid down that the sample size should be 5%, 10%, or 25%. What if the 5, 10, or 25% does not ensure representativeness? So a mere size which is already decided cannot be followed on. So a smaller sample but well selected sample may be very superior to a larger but badly selected sample. So even if I say that 5% is something that is necessary, but I end up choosing the 5% very badly in such a way that it is not representative of the whole population in itself, then the size itself doesn't matter because the way of representing each member within the sample population was wrong. Similarly, if the size of the sample is so small, like less than 30 in quantitative study, then it is definitely not able to represent the universe. And any inference that is drawn from this kind of sample population might be very misleading. So on the one hand, we know that if the size of the sample is very large, then it could be very burdensome. But at the same time, we know if the size of the sample is so small, then it won't be representative, and hence the inference drawn from such sample cannot be considered. Hence, the conclusion we can say is that the sample size should neither be too small nor too large. So we should know what is the optimum size that is need to fulfill the requirement of efficiency. So when we are again coming into the decision of what will be the size of the sample, there are other things that we have to consider, that is what is the size of the universe in itself. So larger the size of the universe, the bigger should be the sample size. So when I said 100 was the size of the universe, then my sample size would have been 80. When considering the confidence interval of 95 and margin of error of 5 plus or minus 5. But if my sample or the universe was 200 in itself, then my sample size from 80 would have increased maybe 200 or 120 likewise. So the larger the size of the universe, the bigger should be the sample size. Now, even though we decide that this is the size of the universe and this is what my sample size should be, even though we are deciding that, what if the resources are not available in itself? So however, like what if, even though we know that these are the individuals or these are the list of members within a certain community, I might not be able to approach them, or they might not be ready to come and be part of the study. So in these scenarios, what will you do? So there are a lot of factors which will be explained now that should be kind of calculated and evaluated when it comes to determining the size of the sample itself. So the next thing will be degree of accuracy or precision. So when I say confidence interval, in a more demanding situation like being able to using a tool or seeing the effectiveness of a tool to be able to screen individuals with suicidal tendency. So in this scenario, I need sample population which has a higher accuracy then only I'll be able to see the effectiveness of the tool to be able to predict the future actions of those who had suicidal ideation. So like that, when the degree of the accuracy is extremely high, or we need to make sure that it is extremely high, then the margin of error or the confidence level of 95 might be increased to 99, because the margin of error that I am ready to able to entertain or even leave it up to the chance will be very low, because the risk that we are taking in itself is very high. So here the degree of accuracy or based on the precision that is required, if I change my confidence interval from 95 to 99, then out of 100, then the sample population that I choose will be definitely more than 80. So according to the experts, according to the purpose of the study, you will have to choose what is the degree of accuracy or the precision that is required. So when you are seeing the effectiveness of an intervention, or the effectiveness of a IQ test, that or effectiveness of any vocational test, on the basis of which an individual will be choosing their career. So all of this is in situations where the risk is quite higher, when there is a false positive or false negative. So at these times, when estimating a sample size, you should also look into the degree of accuracy or precision required. The next is whether to choose a sample from a universe of heterogeneous universe or a homogeneous universe. So if the universe consists of homogeneous units, then a small sample may serve the purpose. That is, if I have, if for example, if I am choosing the sample from psychology class, then all the individuals will have a similar common ground, that the subject that they are sharing is psychology. So their way of learning or exam stress, dealing with exam stress, everything would be similar. So when the universe itself is very homogeneous in nature, then a small sample would be justified. But what if instead of saying psychology student, I am saying students in nature? Then there is students from different arts, humanities, commerce, and different disciplines. Therefore, the characteristics of the individual from each cluster in itself will be different. Hence, a large sample will be needed inevitably. So again, it is not only the degree of accuracy or the availability, but also the homogeneity or heterogeneity of the universe in itself. Then the main point is the nature of the study. So for an intensive and continuous study, a small sample may be suitable. That is, if it is a cross-sectional study, then being able to manage a sample population of more than 1,000 or 2,000 is something that is manageable. But if it is a longitudinal study, or if it is an intervention study, then it goes on about for a long period of time, and the administration and analysis process will again be stretched to quite a long period of time. So here, based on the intensity and how continuous or the duration of a study is, the sample size will also equally vary. The next is the method of sampling adopted. So even if I want to do simple random sampling, and if I do not have a list of all the members that exist in the universe, that is not possible. So I might have to end up doing choosing another kind of non-probability sampling, like either convenient sampling or purposive sampling or accidental sampling or snowball sampling in itself. So the method of sampling adopted. So when I'm doing purposive sampling, then in that scenario, I am choosing members who have certain unique characteristics. So like for example, if I am choosing individuals who had severe depression and who engages in alcohol abuse, it is not as a researcher feasible to be able to find 100 individuals who share the same characteristics. So simple random sampling at this scenario is not possible. Neither a large sample is feasible. So because your method of sampling that is adopted is purposive or purposive in nature, your size of sampling will also might decrease. The next is the nature of respondent. So where it is expected that a large number of respondents will not cooperate and send back the questionnaire, a large sample should be selected, because only when a large sample is selected will there be at the end of it at least a minimum number of respondents who will qualify into the sample. Okay, so now that we have talked about how to come to a conclusion or what are the factors that contribute to the size of the sample, then we come to talk about the biases that exist. So biases, when we say biases, we are talking about the research biases, research or the researchers biases. When we say researchers biases, why is it important to focus on that? Researchers biases can contribute to a lot of sampling error. So when we say sampling error, it can be either a systematic sampling or a non-systematic sampling. So for example, faulty selection. So when I deliberately select it, so in the example of intervention study, where I told you or gave you the example of individuals who had the higher motivation to change. So there, when I'm deliberately selecting that individual, it is not representative of the sample that exists. Not every individual will be motivated to change at the same level. So here there is a faulty selection and I am increasing the probability or in gathering the evidence for the effectiveness of my intervention. So that is like a faulty selection. At the same time, substitution. So substitution of an item in place of one chosen in random sample sometimes also lead to bias. So when we say substitution, like for example, in random sampling, I'm randomly choosing an individual. But when in substitution, I can also say that when, for example, I have a treatment group and a control group. In treatment group, if I see that an individual is not able to perform in the way that I expect them to, then substituting them with another individual whom I know from the control group who is able to perform betterly in that fashion, then that would be substitution, and that is not a representative of the total population itself. Then is the non-response. That is, if all the items to be included in the sample are not covered, then there will be bias even though no substitution have been attempted. So if like for example, the question is, are you a good student? Is such that the most students would succumb to variety and will end up answering S, even though the answer might not be true. Similarly, bias due to faulty collection of data. So any consistent error in measurement will give rise to bias whether the measurements are carried out on a sample or on all units of population. So the danger of error is, however, likely to be greater in sampling work. Bias may arise due to improper formulation of the decision problem or strongly defining the population. Bias observation may result from poorly designed questionnaire or ill-trained interviewer or failure of a respondent's memory. So when we say failure of a respondent's memory, is that when I ask for a family history and the respondent itself forgets to mention that within his history there was some or the other mental health issues that we see. So that is failure of a respondent's memory, which can lead to faulty collection of data. Second is ill-trained interviewer. In terms of ill-trained interviewer, the interviewer in itself is not trained enough to ask appropriate question to be able to elicit the desirable answer. Or it could be the poorly designed questionnaire which fails to measure what it purports to measure. So all of this can contribute to the biases that lead to faulty collection of data. Now, when we talked about biases in the faulty collection of the data itself, there is another kind of biases even in analysis that is conducted. So the biases that arises in the, give me 1 minute. Okay, thank you. Okay, when I say biases in the analysis, then it means to the even process of selecting or even. So when we say biases in analysis, how we previously said that even biases in the selection process or in the data collection process, or even when I said selection of participants or the faulty collection of data, or even in using the analysis. So when we could do parametric, but instead we chose non-parametric measures. So like that, a lot of biases within the analysis itself can contribute to uh, faulty answers or results that are contributed. But so this was the sampling errors that could have been possible. What are the non-sampling errors that we need to discuss? That is either lack of trained and experienced investigators, lack of inadequate inspection and supervision of primacy staff, errors due to non-response from the participants itself, errors in data processing operation, that is if we are using Google Form and Google Form was not able to correctly collect the data, or errors committed during presentation or printing of tabulated results. So all of this could also kind of vary, skew the data or skew the results which are not representative of actual population. So how can we avoid all of this? What is the method of reducing sampling or even controlling non-sampling error? So once the absence of bias has been ensured, attention should be given to random sampling errors. So when we talked about simple random sampling error and the disadvantage, we talked about how there could be a pattern which we do not know about. So how every 10th individual would have been an individual who has highest academic ability. So here, one of the things that you could make sure is that the list that you create is very much random and not on the basis of some automatic method or design that has been created. So apart from reducing the error of bias, the simplest way of increasing the accuracy of the sample is to increase the sampling itself. So when we say quantitative research, the minimum sample size is 30. To be able to have more than 100 is quite of a good way to be able to reduce the error within the bias. The sampling error usually decreases with increase in sample size, and in fact in many situations the decrease is inversely proportional to the square root of the sample size itself. So the control of, when we talk about control of non-sampling errors, we can talk about other things like how we mentioned the biases that arise from the administrator or the analyst in itself. So the increase of complete enumeration of non-sampling errors, and in case of sample surveys, both sampling and non-sampling errors is needed to be controlled and reduced at a level at which their presence itself does not impact the final result. Like for example, even when we choose the purposive sampling or convenient sampling as a method, the disadvantage that we are aware of can be controlled to a certain extent. Similarly, the other non-sampling errors that we talked about, that is lack of trained investigators and all of that, we can provide the investigators with extra or make sure that a certain ability or that the investigators we choose have a certain experience level. So like that, a lot of biases and everything can be rechecked and controlled to ensure that it does not contribute to any non-sampling or sampling errors. Now that we have chosen a sample, the reliability of the sample or the representative of the sample can be tested in a lot of ways. So the more sample of the same size should be taken from the same universe and their results should be compared. So if the results are simple, then the sample will be reliable. So for example, if I have a study about mental health during COVID, which is done in young adult population, and I see that there is this pattern where individuals who were made to be socially isolated, there was increase in loneliness as well. And in another study where in the same population, the same study had taken place, that you can see that the same results were found. So here I have a proof that the sample in my study was also representative as there was evidence of another research to back it up. And the results were itself comparable. So if the measurements of the universe are known, then they should be compared with the measurements of the sample. So in case of similarity of measurement, the sample will be reliable. So that is the overview of the sampling techniques, or what is sample, or what is the concept of the samples that you should be aware of, and in what way will you be able to control or be aware of the biases and the errors that occur. So this is the conclusion of this lecture for today. Yashwati, do you have any doubts?
No, ma'am.
Okay. I hope you got to revise all the topics that you had learned before.
Yes, ma'am.
Sir, are you there? Datta sir?
Hello, Kobita.
Yes, sir.
Thank you. Very nicely you covered the sampling. That is very essential. I think Yashwati has understood
Yes, sir.
the difference between the probability sampling and the non-probability sampling, and what is the importance of the probability sampling,
Yes, sir.
and what is the disadvantage. One major disadvantage is that in case of the probability sampling, you have very clear idea about the units from which you will collect the data. Okay.
Yes.
That is the major problem in case of the probability sampling. For example, household survey. So you know households are there, people are there, and you will collect the data. Okay, and
Yes.
accordingly, you are creating the, in case of the household survey, you can do the random table. So random number you have generated, and based upon that, you have selected the households. That is very nice, but sometimes it happens that you do not have that particular data. Earlier data you do not have. Suppose the current crisis, what is going on in Rajasthan, Kolkata, and other places. Okay, so that is how do you collect the data? So then you have to follow the non-probability sampling.
Yes, sir.
And when you are talking about the item, we are also following the same principle. Okay, there is the population of the items. That means many items are there. Item reservoir are there. And from that item, you can pick up the item. That is possible. But you have to fulfill the representation. That is, for example, there are maybe 1,000 items related to assessing depression. Okay, and you want to select only the 10 items out of that. So how do you select the 10 items out of these 1,000 items? Item reservoir, item bank is there. So how do you collect? So that is very interesting part in case of the item analysis. But okay, but today that is not the issue because Priya will take that class. Due to the internet problem, Priya is not able to take the class today. And Kavita, thank you. Today you have done some interaction. That is good. I hope that is other students, they will join